Alright, so you should have read this before the video. Basically what it says is you always want to see if there's a number that can be factored out of everything first. So if we look at all these, they're all divisible by 2. So we can factor out a 2. When we take out the GCF of 2, undistribute it, that gives us an x squared minus 3x minus 4. Alright, so now since we took out that 2, we still have to keep that 2 there, but we can now factor this just like we would have factored our trinomials, right? X squared minus 3x minus 4. What multiplies to negative 4? 4 and 1. And what adds to a negative 3? It's going to be negative 4 and a positive 1. That factors just as normal, 1 GCF. But it can't be factored. Alright, if there's nothing that comes out of all of them, you have a coefficient greater than 1, so you have this number in front of your x squared, then we're going to have to do a little bit different method. What we do is we split the middle term, split this 3x into 2 pieces, and then we're going to group the terms. So you'll see what I mean on this slide. So here's that same equation. What we're going to do is we're going to go back to making that table, and they need to multiply and add to something, right? But before, the table was really simple just because it was always a 1 here. Now it's a 2x squared. So they need to multiply to 2x squared, and they need to add. So I'm getting that 2x squared from this times this. So that times that, 2x squared times 1, or 1 times 2x squared is just 2x squared. And then they need to add up to this. So this is what they need to add to. They need to add to 3x. So what multiplies to, really worth looking at, what multiplies to a 2 and adds to a 3? So we've got 1x and a 2x. 1x times 2x is 2x squared. 1x plus 2x is 3x. So that's our group. Now what we do is we then take this middle part and split it into 2 pieces. And I'll show you in a second. It doesn't matter which way we split it. So the first time I'll do it this way. 2x squared stays. And we're now going to write 3x as 1x plus 2x. Right? Because 1x plus 2x is the same as 3x, but that's going to make our factoring easier. Now what I do is we think of these as groups. I'm going to think of just the group of the first 2 terms. What can I factor out of both of these? Well, I can undistribute an x. That's the only thing that divides out of both. And it leaves me with a 2x and a plus 1. Right? Check in your head real quick. X times 2x is 2x squared. X times 1 is 1x. Good. Now I'm going to factor this group. Now 2x and 1, there's nothing that goes into both of these except for a 1. So it was this group plus this group. That's why I still have a plus here. I'm factoring out a 1. That leaves me with a 2x plus 1. Right? And if I redistribute that 1, it works. Okay, so to exemplify what we're doing here, imagine if I had an x times something. I don't know what it could be, anything. X times an x times a 1, x times anything. Plus a 1 times something. Well, the GCF here is just this triangle. That's what's being multiplied by both, so I can divide it out from both. So I can right? So that's just kind of the idea here, right? X times something plus 1 times something, we can undistribute it or factor it out. It just so happens that our a packet of variables and numbers. This is what I'm undistributing. So I'm undistributing the 2x plus, just like I undistributed here, and that leaves me with an x, 1. And now this factors. We're done. That's our answer. If we wanted to check our answer, we would go back and FOIL it out, right? So this is just to check, to make sure that we did it right. 2x times x is 2x squared. 2x times 1 is plus 2x. 1 times x is plus x, or 1x, and 1 times 1 is plus 1. Simplify and you get 2x squared plus 3x plus 1. Right? So that was just to check our answer. Really what we want is this. This is our final answer. This is the factored form of this. Alright, so let's see just one more example here. First thing I ask myself, can I factor anything out of all these terms? Is there any number or variable or anything that comes out of everything? And no, there's nothing I can divide out of a 3x squared or 4x and a minus 4. So now what I'm going to do is I'm going to look at what multiplies to this times this. So I need something that multiplies to a 3x squared times negative 4 is a negative 12x squared. That's what it needs to multiply to. And it needs to add up to. So start with the multiples and then think about what adds. It needs to add up to our 4x. So I first think about the multiples. Now I have a positive and a negative because it's got to multiply to a negative. So that could be, has to end up with a positive. So if I'm multiplying a positive and a negative, and then I need to add them to get a positive, the bigger number has to be positive. So I'm going to do a 12 and a negative 1, a 6 and a negative 2, 4 and a negative 3. Now, if you're clever, you'll realize right away 6 minus 2 is 4. So it really should be 12x, negative 1x, 6x, negative 2x. So they actually multiply to give us negative 12x squared. And then they add up to a 4x. Now, if you don't notice this right away, that it's this one, then you can go through all the possibilities, write out all the sums. So this is 11x, this is 1x, and you see that none of these work. That doesn't work, that doesn't work. This is our pair. So 6x and negative 2x are our numbers we're going to use. So that means we're going to split this up into two pieces. So we still have our 3x squared, and we have our plus 6x and minus 2x and minus 4. Now remember, it doesn't matter whether negative 2x goes here or goes there, just as long as you break it into those same two pieces. And now we're going to factor by grouping. So method one for factoring by grouping is this, and then the last couple minutes of the video I'll be doing my grid method that I showed you before. So method one, I just factor this group, and I can take a 3x out of both of these terms, and that leaves me with an x plus 2. Now whenever I have a negative and a negative, I need to have that negative somewhere, so I'm going to factor out a negative 2 here. And that gives me, factor a negative 2 out of that, gives me just an x. Negative 4 divided by negative 2 is a positive 2. And now, just as before, we can factor out or undistribute the x plus 2 from each of these terms. So I can take it out of here and divide it out of here. So x plus 2 times leaves me with a 3x and leaves me with a minus 2. That is my final answer. And if I were to check it and go back and plug it back in, it would, or if not plug it in, if I were to distribute these, FOIL it out, or grid method it out, I would get that back. Now method 2 is going to be once we get from this spot. Alright, so once we've done this, we have to do this, then we do method 2. So what I do is I rewrite my grid. I'm going to use this multiplying grid, but I'm going to use it backwards. So the 3x squared goes here, the negative 4 goes here, and now these two boxes are going to have a negative 2x and a 6x. Doesn't matter which one, I'll just do the 6x here and a negative 2x there. Now what I do is I look for the greatest common factor of each of the columns and each of the rows. So what can I divide out of each column? Well, I can only divide out an x here. And here I can divide out a 2. That works, right? And it's a positive 2. Here I can divide out a 3x. And here I can divide out a negative 2. So those are my factors. So that tells me that it's x plus 2 times 3x minus 2. And that's the same answer we got here, just a little different method. So if I go back and try the first one, so once we've done this first step, we look at what multiplies to the 2x squared. Remember, this is the first problem we did. We already got the answer. I'm showing you how to use this method now. So we know that it's a 1x and a 2x. It will add up to a 3x and multiply to a 2x squared. So then we draw out our grid. We know right away that we got to put a 2x squared here. And we put the last term here, so that plus 1. write 1 or plus 1, whichever you like to do better. And then we're going to take these. So I'm going to write the 1x in either spot. I'm going to put it here. And I'll put the 2x here. The key is knowing how to split the 3x into these two pieces. So now I factor across here. Or I'll do it the same way as I did last time. I'll factor the top first. So factor the column. That leaves me with a 2x will come out of both of those. All I can get is a 1 out of both of those. And then if I divide what I can out of here, it's just an x I can divide out. And then here I can only divide out a 1. And you got to take out some greatest common factor or this method doesn't work. So this gives me a 2x plus 1. So my factors are 2x plus 1 and x plus 1. So we'll get x plus 1 and 2x plus 1, which is precisely the answer we got when we did it the other way. Same answer. So you can do whichever method you like, and make sure that you do try these two problems before next class.